Alright, this is our video on section 3.4, writing linear equations. I'm going to go ahead and get started. There are two different forms that we could write linear equations in. First one is point-slope, and the second one is slope-intercept. You should have seen slope-intercept before, you may have seen point-slope before, but both of them are different ways to write linear equations. We're going to start with point-slope, and point-slope form is y minus y1 equals m times x minus x1. And in that formula, m is the slope, and x1, y1, you're going to put values in for those. That is any point on the line. Okay, it doesn't matter, and they will give you that point. X and Y that don't have little ones on them, they stay variables because we need those to be an equation. It needs to be x on one side, y on the other. But m is the slope, x1, y1 is any point on the line. Let's go ahead and do our first example then. It says, give an equation in point-slope form that passes through 3, 4 and has a slope of 3. Well, remember, points are written x, y, so the point they give us here is really our x1, y1. And then we said slope is m, so that 3 is the m. We're going to just plug things into our form now. And remember, it is y minus y1 equals m times x minus x1. So y minus y1 in our problem was 4 equals m is 3, x minus x1 was 3. And that's it. We are finished. That is all we have to do for point-slope. We take and we just plug in the values that they give us. Plug in your x1, your y1, and your slope. Now, if all it asks for is point-slope form, then you can just stop. You don't have to go any farther. We're going to continue because it'll be important later on when we talk about slope-intercept. We're going to go ahead and simplify this because it'll be important. It's a shortcut to something else. Alright? If we have y minus 4 equals 3 times x minus 3. If we're going to simplify that, we need to distribute our 3. So y minus 4 equals 3 times x is 3x, and 3 times negative 3 is 9. One more step, we're going to add 4 to both sides. So y equals 3x. Negative 9 plus 4, negative 5. Okay, so if we kept going, we would get y equals 3x minus 5. And the reason we kept going is because that is slope-intercept form. And what I want you to see is that you can use point-slope to get to slope-intercept. And a lot of times people find that easier because they don't have to go through and find the y-intercept. And we'll talk about how to do that in a second. You can use any point on the line, and as long as you know any point in the slope, you can simplify that point-slope form to get slope-intercept. So that's an option for you. You can do that. Now we're going to go ahead and talk about slope-intercept form, and then we'll compare the two, and you can pick whichever one is easier for you. Slope-intercept is y equals mx plus b. M is still the slope, just like it is in the other form. And b is the y-intercept. And this is how the two forms are different. The y-intercept is a specific point on the line. It always has to have 0 first. Okay, it's 0b. And it's where the line crosses the y-axis. And I know that's sloppy, I wrote it out of order. It's where the y crosses the x-axis. But it's a specific point on the line, unlike point-slope. Because in point-slope, we could use any point. In slope-intercept, it has to be the intercept. So our example, this is example 2 now, is to give an equation in slope-intercept form that passes through 6, negative 1 and has a slope of 1/2. Right, so we're going to use slope-intercept form this time. Y equals mx plus b. Well, we know the slope. That's m. We don't know b, though, because this point that they give us is not 0 in a number. Okay, so don't tell me negative 1 is b, because it's got a 6 first in the point. What we do know, though, is remember that points can be written x, y. So that our x value here is 6, and our y value is negative 1. And we can go through and algebraically find b. So we're going to plug in some values. y is -1 according to the point they gave us. Our slope was 1/2. And then the x is that 6 plus b. Now we're going to simplify that, and we're going to figure out what b is. So -1 equals 1/2 times 6. That's really 3 plus b. Subtract 3 from both sides. So now b is -4. Now the last thing we got to do is rewrite it. So it's y equals, remember x and y, like we said over here for point slope, they need to stay variables. They need to stay letters. We only switched them out on this first part so that we could find b. When we write our answer, though, they're going to become variables. They're going to stay variables. So y equals, m was 1/2, x stays a variable, and we got b to be -4. There's the answer to our problem. Now, you may think that one's easier than going through and doing point slope. Doesn't matter to me which one you use, but on the test, it will ask you for slope intercept. So you can either go through and find b, or you can use point slope and simplify it so that you can get slope intercept form. Now we got one more example here, example 3. It's the same as example 1, but this time we're going to use slope intercept to find it, just so that you will see that you get the same answer either way. So y equals mx plus b. Our point tells us the x and the y. They give us m, and we're looking for b this time. So let's plug in what we know. Y is 4 equals 3 times 3 plus b. First 3 is our slope, second 3 is our x. 4 equals 3 times 3 is 9 plus b. Subtract 9 from both sides, and we get b to be -5. And then when we rewrite our answer, remember x and y stay variables, so it's y equals, our slope was 3, because that's what they told us here. So it's 3x. We found b to be -5. And there's the answer to our problem, y equals 3x minus 5. Notice it's the same thing you got on the other side. Okay, so again, you can use point slope to get slope intercept, or you can just go through and use slope intercept the whole way. It does not matter. Real quick before we finish our notes for this section, we're going to talk about horizontal lines and vertical lines and what their equations look like. Now, an easy way to remember the difference is, and somebody told me this, it's just a mnemonic device that will help you remember them, is HOI, VUX. Okay? The HOI part is the horizontal line aspect, and the VUX part is the vertical line. HOI stands for horizontal line, has a 0 slope, and the equation, which is the important part, the one we're going to talk about right now, is always y equals a number. Just a number. There's no slope, there's no mx part in this equation. Since the slope is 0, it would just cancel itself out. So it's y equals a number. Now, if you were going to graph that, you would go to the y-axis, and you would find whatever number that is. So suppose we had y equals 2. We would go to wherever 2 is on the y-axis, and we just draw a horizontal line through it. That's the equation, and that's how you graph that. Okay? Horizontal line, again, has a slope that's 0, and the equation is y equals a number. Vertical line, the VUX part, okay, vertical line has an undefined slope, and those equations are always x equals a number. Okay? If you're going to graph those, let's graph x equals 2, so you can see the difference between y equals 2 and x equals 2. Now, this is the different one for a vertical line. It's the only one that's x equals, and that's because it has an undefined slope. Okay? It's the only one with an undefined slope. It's the only one with a 0 in the denominator. Everything is different about a vertical line. So if you got a special case for just about anything, it's probably going to be a vertical line. So we've got x equals here. Now, like we did with our horizontal line, we're just going to go to wherever x is 2, not where y is 2. So we're going to go to the x-axis, find 2, and we draw a vertical line through it. And that's how you graph x equals 2. So y equals 2 is a horizontal line, x equals 2 is a vertical line. Remember that. Hoivux will help you remember it. Now those are our notes for section 3-4. The important parts were point-slope form, slope-intercept form, the fact that point-slope reduces to slope-intercept, and then this Hoivux part at the bottom, graphing horizontal and vertical lines and what their equations look like. Make sure you understand all that, and those are your notes for section 3-4.